So here we are where we left off with our unit circle, and we had labeled all the terminal points of the quadrantal angles. And so for example, over at 180, our terminal point was -1, 0. Remember what that means? That means that we can find that the cosine of 180 degrees is equal to -1. The sine of 180 degrees is equal to the y coordinate, 0. And then we said the tangent was going to be sine divided by cosine. So we could say that tangent 180 is the sine divided by the cosine, or y divided by x, however you want to think about it. And that gives you tangent also equal to 0 at 180. All right, so you can find the sine, cosine, tangent, and eventually all the reciprocal functions of all of the quadrantal angles now. But what I want to focus on now is the red, blue, and purple spokes in the first quadrant. Okay, so those are the 30, 45, and 60 degree angles. So let's start off with 30. All right, so this is my 30-degree angle. And again, we're not drawing those arrows because we don't want it to get too crowded with all these angles here. And 30 degrees, if you convert that to radians, you get pi divided by 6. All right. Let's see, the blue angle is 45 degrees. If you convert that to radians, you get pi over 4. And the purple angle is 60, which if you convert to radians is pi over 3. It's very helpful if you can memorize the radian conversion for 30, 45, and 60 degrees. I just always remembered that 30 and 60 kind of swap 3s and 6s for the denominators and radians, and 45 gets the 4 underneath the pi. All right, so we know the 30, 60, 90 triangle. We talked about that when we learned right triangle trigonometry. So let me copy that down. All right, so we went to great lengths to fill out this triangle. All right, and we filled that out in the first place because we knew sine of 30 was equal to 1/2. All right, so let's start off with 30 degrees. I'm going to fill out its terminal point. So here's its terminal point. And I know I need to put the cosine of 30, comma, the sine. So the cosine is adjacent over hypotenuse, square root of 3 over 2. And the sine is 1 over 2, opposite over hypotenuse. All right, so we'll use the same triangle to figure out the terminal point for 60 degrees. All right, so cosine has to be the x coordinate. Cosine of 60 is adjacent over hypotenuse, that's the 1/2. Sine of 60 is opposite over hypotenuse. Opposite of 60 is root 3 over 2. All right, so 30 and 60 swap x and y coordinates because they swap cosine and sine. All right, for 45 degrees, let's look at a triangle that has 45-degree angle. So I'm going to draw a right triangle with a 45-degree angle here and a 45-degree angle here, right? 45 plus 45 plus 90 would give me my 180 degrees. All right, and it should hopefully make sense that the vertical side and the horizontal side of that triangle should be the same length. They both have a 45-degree angle across from them. So you can build this triangle with any number that you want, vertical and horizontal being the same length. Now, it kind of makes sense to put a 1 and a 1. I'm actually going to put a square root of 2. You'll see why in just a second. So both of those sides have to be the same length because this is an isosceles triangle. But I'm choosing root 2 and root 2. And the reason why is because it gives us the same hypotenuse as the 30, 60, 90 triangle. So let's just double check that that works. We would do our a squared plus b squared equals c squared to find that hypotenuse. So square root of 2 squared is 2, and again 2. And you get c squared equals 4, or that c is equal to 2. If I take the square root of both sides. All right, so you get the same 2 hypotenuse on this triangle if you make this rather clever and weird triangle that has root 2 as its side lengths. All right, so if I use that triangle for the sine and cosine of 45 degrees, All right, pick either 45-degree angle. Its adjacent side and its opposite side are the same. So we're actually going to get the same sine and cosine for 45 degrees. Adjacent over hypotenuse, and then opposite over hypotenuse. Okay, so the sine and cosine of 45 degrees, or pi over 4, are both the square root of 2. All right, so now that we've got most of the unit circle filled out, all we're going to have to do is fill out the rest of those spokes in quadrants 2, 3, and 4. It's going to be really easy because the unit circle has a lot of symmetry going on, and I'll see you there.